Hello, and welcome to this edition of the Ward's Intelligence 6-Minute Webinar. I'm Drew Winter, a Senior Analyst at Ward's Intelligence, and the topic is lightweighting versus bigger batteries in EVs. The inspiration for this research project was a response from a previous survey related to lightweighting. It no longer is a question of taking weight out of structure, it's about getting more energy density into the battery. In the future, will automakers be investing more in bigger and better batteries and less in premium materials such as carbon fiber and aluminum? For answers, we surveyed engineers and designers at automakers and Tier 1 suppliers who are involved with R&D, engineering, design, and production and engineering. Materials always have been technology disruptors. We actually describe the evolution of mankind by materials, the Stone Age, the Bronze Age, and the Iron Age. Materials technology changed our tools, our weapons, and our society. In the modern world, plastics, composites, and aluminum are disruptors. When Ford faced pressure to improve fuel economy in the 1970s, it showed off a Ford Galaxy made of carbon fiber that was 1,200 pounds lighter than a conventional car. Starting in the 1970s, premium lightweight materials were viewed as the answer to the auto industry's growing troubles with fuel efficiency and emissions. Steel was considered the dominant old material that needed to be replaced. It was too heavy, it rusted, and it was hard to form into aerodynamic shapes. The result was from the early 1980s to the mid-2000s, we saw hugely ambitious programs in the US and Europe aimed at using alternative materials. Most were not successful. As we look to the future, we now, how electrification and other technologies might change materials and architectures over time is something everybody wants to know. In our survey, 72% anticipate at least some difference in 5 years, and within 10 years, virtually all respondents anticipated some change, with 44% saying they would be totally different. But we're not talking about cell phones here. We're talking about vehicle body structures that must protect people in terrible crashes. In 35 years, high-volume vehicles have gone through about 2 major changes in architecture. Cars and light trucks have transitioned from body-on-frame to unibody construction, and now most electric vehicles are based on some sort of skateboard architecture. There are notable exceptions, such as the aluminum-intensive Ford F-150 and the Tesla Cybertruck, but dramatically new vehicle architectures in high-volume vehicles typically have not done well. For instance, Audi made a huge push into aluminum bodies in the 1990s and the mid-aughts. It started with an all-aluminum luxury car and ended when the world's first high-volume all-aluminum production car didn't attract buyers. The A2 was 40% lighter than a steel car, it was extremely aerodynamic, and it could get almost 80 mpg. But European consumers thought it was overpriced and plain-looking, and they didn't buy it. You can't expect value-minded consumers to pay a premium for engineering properties that they don't understand or care about. This is the same problem BMW ran into with carbon fiber. 4 decades after Ford showed off its carbon fiber car, BMW launched its i brand. It featured the i3 and i8, the first mass-produced carbon fiber-intensive electrified cars. Many thought BMW's high-tech electrified vehicles would put Tesla out of business, but both BMW models sold poorly and were phased out. This quote from the head of BMW's I division confirms the premise of our study, at least for carbon fiber. He makes it clear that now that it's possible to make more energy-dense batteries, BMW isn't doing any new high-volume EVs with major CFRP structures. BMW's next EV is based on the company's new 5th-generation architecture, and it will share a platform with conventional BMW models. Cost always is a key factor in automotive materials, and our survey shows cost pressures are going to become even more intense going forward. 94% of respondents said the new focus on electrification and self-driving technologies has had an impact on the funding of body and chassis engineering and R&D, including 46% who report it had a major impact. When it comes to the key driver of respondent companies' materials portfolio, cost by far is the most important factor. It's also the most important factor for personal EVs and for fleet and service vehicles. Cost, cost, cost. However, when we look at the willingness to pay a premium for weight savings, the outlook is it isn't quite that bleak. 24% said they were willing to pay $1 to $3 per pound for lighter weight, and 44% said they would be willing to pay something less than $1 per pound. Clearly, using premium lightweight materials is working better for some than others. Ford invested heavily in an aluminum-intensive F-150. None of its competitors have followed this strategy, but it remains the best-selling vehicle in the U.S. So, has lightweighting reached its cost efficiency limit? Respondents are divided on this, mainly because some automakers are pursuing concurrent strategies. Tesla uses a combination of aluminum and steel in its high-volume Model 3 and Model Y models, but it's also investing heavily in new aluminum forming and casting technology to create large structural parts for current and upcoming models. On the other hand, it's investing in that all-new stainless steel exoskeleton architecture with its new Cybertruck. When we asked directly whether automakers would quit paying premiums for lightweight materials as the cost of batteries decreases, 46% of respondents said they would likely stop paying, 26% said they wouldn't, 29% said they were undecided. It's a complex issue, but as the cost of batteries continues to decline and energy density grows, it seems inevitable that the focus will increasingly shift away from lightweight body structures to getting more energy density into the battery. I'm Drew Winter, and thanks for tuning in to this edition of the Ward's Intelligence 6-Minute Webinar. To make sure you don't miss future episodes and other summer Festival of Automotive content, follow the link listed below on this slide and in the description box below. Thank you.